Hi, my name is John Kwak. I'm a director of business development at OE Solutions, and I'm gonna explain about a new product that we are introducing to the market, Smart SFP, and I'm gonna talk with the title "Bringing Intelligence to SFP." Smart SFP is a product that OE Solutions and AIM Valley have teamed up to develop it together. It is basically putting a link OEM and service OEM feature into the SFP. We are naming this product Gigabit Ethernet Smart SFP, and this product increases the network performance management and SLA assurance capabilities. As you can see in this picture summarizes the functions of a Smart SFP very well. It is a conventional SFP, as you see in the picture, but these blocks with the color basically indicates the functionality that we are adding to the SFP. 802.3AH EFM, 802.1A GCFM, Y.1731, and remote DDM. As mentioned in the bullet items, Smart SFP is a conventional SFP if the user chooses not to implement it. Some of the value offerings that Smart SFP brings to the customers, it reduces the cost in installation of OEM features, so reduces the capex expense, and also remote troubleshooting is capable, so it reduces the maintenance cost. And basically this SFP is a zero footprint for implementing OEM features. It significantly saves the rack space, and by having all these and having lower power consumption, it offers lower carbon footprint. Applications. Smart SFP can be used in many different applications. Some of the examples are shown here: a mobile backhaul, telco wholesale, broadband access infrastructure and backhaul, and for business access, Ethernet. For people who are not familiar with OEM functions, I would like to give some background information. First of all, Ethernet demarcation. Ethernet does not have a clear demarcation point, and that actually makes an obstacle to become a carrier grade. And by having Ethernet demarcation, it provides separation between the carrier Ethernet WAN and enterprise LAN. It's explained here in the picture, and the demarcation point can be implemented by NID or NTE. NID is a network interface device, and NTE is a network termination equipment. So by having this demarcation point, you can have a carrier Ethernet visibility on carrier Ethernet network side and customer network side. And this enables the testing and monitoring of both networks, and then NID functions can be in standalone device mode, or it can integrate it into the first mile transport device or in the CPE equipment. So what is Ethernet OEM? It benchmarks existing WAN technologies, and Ethernet OEM feature is a key differentiator to make the network carrier Ethernet grade. Two versions that we are introducing in March 2012. First one is EFM. It is a link OEM based on IEEE 802.3AH, and it monitors the link operation. It uses the slow protocol frames called OEM PDUs, and it actually stays within the link. It does not go beyond the link, and the picture here shows the simple link between the carrier Ethernet network edge and the demarcation point in the customer premise. Key functions in EFM are OAM discovery, link monitoring, fault signaling, and remote loopback. And some of the OAM events are link fault, dying gasp, and critical event. Then the second version of Smart SFP is based on CFM, and it is end-to-end service OAM based on IEEE 802.1ag and ITU Y.1731. As you see here, there are two customer premises at the end of the services, and between these end-to-end connectivity with the OAM, end-to-end service OAM, you can detect, verify, isolate, and report connectivity faults. And this one is implemented in regular Ethernet frames in band, and the key mechanisms are shown in this picture. And the protocols implemented in our SFPs are continuity check and loopback. So how does Smart SFP work? Basically, our Smart SFP takes a role as an NID. The picture shown here is a typical setup for demarcation box. So there is a connection between metro core node and the demarcation device, and then the connection is between demarcation device and the customer edge equipment. So by having our Smart SFP, you can replace the demarcation device in the middle, and Smart SFP itself works as a demarcation device, and it can plug right into the customer edge equipment, and it integrates OE conversion, which is a typical functionality of SFP, but we do have a protocol function on top of OE conversion in a single SFP. Because of this, our Smart SFP can be offered in many different flavors. Basically, it can be offered in all our Gigabit Ethernet products, namely 500 reach from 500 meter all the way up to 80 kilometer. It can be provided in both single fiber version as well as the dual fiber version, and it can be also implemented in both gray optics or CWDM optics. So graphically, I wanted to show here how Smart SFP works. So for EFM link OAM case, Smart SFP, once it gets plugged in, it can OAM can be discovered automatically, and it does monitor link. And also, once you lose the power on the customer equipment side, you actually get the signal back into the network, which is called dying gasp. This can be differentiated from fiber cut. It is indeed power of failure in the equipment side. Also, for DDM functions, typically it is only available in the local level, only on the board, whereas on the board that SFP is located. But in this Smart SFP, you can actually access the DDM information from remote side. So it is with the remote DDM functionality. So carrier Ethernet network side can pull the information from the Smart SFP, and all the information in DDM A0H and A2H can be accessed from the remote location. This picture shows end-to-end service OAM. Basically, it does sends out the continuity check signals, CCM signals, to each other. It can be set in a desirable interval, and it basically checks the heartbeat of the connections. Also, it can have a loopback function from one end to the other. Then I would like to compare our Smart SFP to some of the competing technologies in the market. As I have explained, we are introducing two different versions of Smart SFP. First one is a link OAM, and the second one is a service OAM Smart SFPs, and both versions do follow standards. Link OAM follows IEEE 802.3AH, and Service OAM version follows IEEE 802.1AG and ITU Y.1731. In our Link OAM case, you only need Smart SFP in customer equipment side. You can just have a conventional SFP on the other end. There are two different competing solutions in the market. One is using an ASIC technology which does not follow the standards, and also another solution using optical modulation, and that basically has only the DDM and the dying gas function. It does not follow 802.3AH. And also in that solution, you do need to have their version of a Smart SFPs at both ends. I would like to wrap up my presentation here. I would like to thank everyone for watching this video. And for further information on our Smart SFP, please contact our website www.oesolution.com or come to www.smartsfp.com. Thank you.